and welcome to the Midnight Scientists. I'm so very glad you could join me tonight. You found a quiet space, a place to unwind, and together we're going to drift gently, weightlessly, into the vast and peaceful sky above us. Tonight, we will not be striving or studying. We will simply be floating, allowing our curiosity to guide us softly through the secrets of the weather. We will explore the science behind the softest breeze, the deep and distant rumble of thunder, the delicate, silent fall of a single snowflake, and the gentle, life-giving warmth of a sunlit afternoon. Think of this as a gentle invitation, an invitation to leave the day behind, to release your thoughts, and to float among the clouds, all while you remain perfectly safe, perfectly comfortable, tucked in and cozy, wherever you may be. Allow your body to grow heavy, your shoulders to soften and release, and your breath to flow in its own natural rhythm, long and slow and easy. There is nothing for you to do right now, nowhere else to be. Simply rest and listen. Our journey tonight is one of gentle wonder. While we will be exploring the beautiful mechanics of our world, this journey is designed purely for your relaxation, to help you unwind and ease into a deep and restful slumber. If a thought captures your interest, feel free to follow it like a passing cloud. And if your mind begins to drift, allow it to. That is why you are here. So close your eyes if you haven't already. Take another slow, deep breath, feeling the air fill your lungs. And as you exhale, let go of any tension you might be holding. Tonight, we are simply going to wonder together about the elegant science that surrounds us, the science behind every raindrop, every rainbow, and every quiet sigh of the wind. Our journey begins. Now, let us begin our journey by becoming aware of something that is with us always, in every moment, with every breath we take. It surrounds us and protects us, an invisible ocean of gases, a vast and gently swaying sea we call the atmosphere. We live our lives at the very bottom of this ocean of air. Unlike an ocean of water, this one is weightless, silent, its currents moving so softly, they are often felt only as a gentle touch against the skin. This atmosphere is the grand and peaceful stage upon which all weather unfolds. Imagine the earth as a beautiful, smooth apple. The atmosphere would be like the skin of that apple, a thin, delicate, and vital layer hugging the surface. When you gaze up at the vast blue sky, it seems endless, but most of it is held in a surprisingly shallow band around our world. This ocean of air is made of layers, like the soft strata of a geological painting. Each layer has its own unique character, its own quiet purpose. We reside in the very first layer, the one closest to the earth, known as the troposphere. The troposphere is our home layer. It is where we live and breathe. It is where the clouds form their soft white shapes, where the rain is born, and where the winds begin their slow and ancient dance. It stretches upwards for about 7 miles, a cozy blanket of air where all the weather we experience takes place. If we were to float higher, we would drift into the stratosphere. This is a calm, clear realm, home to the ozone layer. Think of the ozone layer as the Earth's own sunglasses, a gentle filter that shields us from the sun's more intense rays, allowing only the soft, life-giving light to reach us. Higher still, we would find ourselves in the mesosphere, a place of deep twilight, where meteors, those falling stars you might wish upon, burn up in brief, beautiful streaks of light, a silent fireworks show in the upper reaches of our world. Beyond that lies the thermosphere, a realm of incredible quiet and stillness. Here, the air is so thin, the molecules so far apart, that they hold vast energy from the sun. It is a place of auroras, of shimmering, silent curtains of light that dance near the poles, and where satellites glide on their lonely, peaceful orbits. And at the very, very edge, where our world whispers into the vastness of space, is the exosphere. This is the final, feathery fringe of our atmosphere, where a few stray molecules of air simply drift away, becoming part of the great cosmic beyond. But for now, let us return, drifting gently back down, through the silent thermosphere, past the glowing mesosphere, through the calm of the stratosphere, back down into the soft, familiar embrace of the troposphere, our home. The air here, the air you are breathing now, is a simple, perfect blend, mostly nitrogen, and the oxygen that gives us life, with just a trace of other elements and a gentle mist of water vapor, the very ingredient of clouds and rain. Now let us consider how this air behaves, for this is the very heartbeat of weather. Air is a fluid, just like water. It flows, it swirls, it rises and it falls in a slow, constant ballet. The fundamental rhythm is simple. Warm air rises, and cool air sinks. When the sun bathes the earth in its light, it doesn't warm everything evenly. The land warms at a different pace than the deep, slow oceans. The dark soil of a field warms differently than a snow-capped mountain. This beautiful, uneven warmth creates gentle pockets of rising warm air and sinking cool air. And because nature always seeks harmony, always seeks balance, the atmosphere is in a constant, quiet state of motion, trying to even things out. Imagine a patch of ground, warmed by the afternoon sun. The air above it becomes buoyant and begins to rise, a slow, invisible column of warmth ascending into the sky. As this air rises, it expands and cools, and cooler air can't hold as much invisible water vapor. So if there is moisture in that rising air, it begins to gather, condensing into impossibly tiny droplets, so small and light that they float. And when billions of these droplets gather together, a cloud is born. Meanwhile, the cooler, denser air from the surroundings gently flows in to take the place of the air that has risen. This beautiful circular movement is called convection. It is the same gentle process that swirls the steam above a warm cup of tea, just happening on a vast planetary scale. It is the slow, deep breath of the atmosphere, the sun's embrace, and the great circulation. The sun, our star, may be 93 million miles away, but its gentle, persistent light is the ultimate source of all the weather on our planet. It is the engine, the conductor of the great atmospheric orchestra. The sun's energy arrives as light, warming the surface of the earth, the ground, the oceans, the leaves on the trees. These surfaces then gently radiate that warmth back upwards, warming the air from below. It is a slow, indirect process, like a warm stone gently heating the air around it. Because our Earth is a sphere, this sunlight doesn't fall evenly. The equator, the belt around the Earth's middle, receives the most direct and concentrated light. The poles, at the top and bottom of our world, receive the light at a low, glancing angle. This creates a constant and beautiful difference in temperature. The tropics are perpetually warm, while the polar regions remain perpetually cool. And the atmosphere, in its endless quest for balance, responds to this by setting up vast, slow-moving currents. Warm, light air near the equator rises, creating a gentle lifting motion. This air travels high in the atmosphere, moving slowly towards the poles. As it travels, it cools and grows heavy, eventually sinking back down towards the Earth in the mid-latitudes. From there, it flows gently back towards the equator along the surface. This enormous, slow-moving loop of air is called a circulation cell. There are 3 of these vast and visible rivers of air in each hemisphere, all working together in perfect harmony. They are the great conveyor belts of the atmosphere, constantly transporting warmth from the equator towards the poles and returning cooler air to the tropics. It is the Earth's way of sharing the sun's warmth. Within these great cells, we find the major wind systems of our planet. Near the equator, the steady and reliable trade winds flow. For centuries, sailors knew they could trust these winds to guide them across the vast blue oceans. In the mid-latitudes, where many of us live, the prevailing winds are the westerlies, which flow from west to east, gently pushing our weather systems across the continents. And near the poles, the polar easterlies bring cold, dense air outward from the Arctic and Antarctic. These vast flows of air would travel in straight lines, but for one last, elegant piece of physics, because the Earth is spinning, any moving object on its surface, including the air, is gently guided into a curve. This is the Coriolis effect. It is not a force, but a consequence of perspective, of moving across a rotating sphere. In the northern hemisphere, winds curve gently to the right. In the southern hemisphere, they curve gently to the left. This effect is subtle, but over vast distances it choreographs the beautiful swirling patterns of our weather systems. It's why storm systems spin not in chaotic lines, but in graceful sweeping spirals. High above us, where these great air masses meet, we find the jet streams. Imagine them as shimmering ribbons of fast-moving air winding their way around the globe. They are rivers of wind, flowing miles above the surface, steering weather systems and shaping our seasons. Flying from west to east, an airplane might catch a ride on this atmospheric river, shortening its journey. And finally, there is the Earth's tilt. Our planet does not sit straight up and down as it orbits the sun. It is tilted by about 23.5 degrees. This gentle lean is the reason for our seasons. As the Earth travels on its year-long journey around the sun, this tilt means that different parts of the planet are angled more directly towards the sun's light. When the northern hemisphere is tilted towards the sun, the light is more direct, the days are longer, and we experience summer. At the same time, the southern hemisphere is tilted away, experiencing the gentle quiet of winter. 6 months later, the roles reverse. This slow, yearly rhythm of changing sunlight is the deep breath of the planet. It changes the patterns of warmth and coolness, which in turn influences the winds, the storms, and the vast ocean currents. It is a delicate and reliable dance that has been playing out for billions of years, a celestial clockwork that brings the endless, beautiful variety of our seasons, the secret life of water, clouds, and rain. There is a secret ingredient in our atmosphere, an invisible element that you usually don't notice until it reveals itself in the most beautiful ways. That ingredient is water. Drifting is a fine, invisible vapor. It is the soul of our weather. It creates the clouds, the rain, the snow, and fuels the sky's most expressive moods. We feel this invisible water as humidity. It is simply water in its gas form, held in the air. Warm air can hold more of this water vapor, which is why a summer day can feel so full and lush. Cold air can hold less, which is why winter air often feels so crisp and clear. When the air contains all the water vapor it can hold at a certain temperature, we say it is saturated. This is the magical point where the invisible becomes visible. This is the moment a cloud is born. Clouds, those soft white blankets that drift across the blue canvas of the sky. They may look light and ethereal, but they are made of countless tiny droplets of liquid water or delicate ice crystals, each one clinging to a microscopic speck of dust or pollen. It takes millions of these tiny droplets to form a single raindrop, an average puffy cumulus cloud, the kind you might imagine on a perfect summer day, can hold hundreds of thousands of pounds of water, all floating effortlessly, suspended by the gentle rising currents of air from below. The journey of this water is a perfect, endless circle. The sun's warmth gently lifts water vapor from the surface of oceans, lakes, and rivers. This process is called evaporation. This warm, moist air rises, and as it ascends into the cooler, thinner air above, it cools. As the air cools, it can no longer hold all of its invisible water vapor. The vapor condenses, changing from a gas back into tiny liquid droplets, forming a visible cloud. The type of cloud that forms depends on how the air is moving. If the air rises gently and slowly over a large area, it forms stratus clouds. These are the soft gray sheet-like clouds that can fill the entire sky, creating a peaceful overcast day where the light is soft and diffused. If the air rises in stronger, more focused columns, it forms cumulus clouds. These are the detached, puffy, cotton-like clouds with brilliant white tops and flat gray bases. They are the classic clouds of a fair weather day, drifting lazily across the sky. High in the atmosphere, where it is very cold, we find cirrus clouds. These are thin, wispy clouds made entirely of ice crystals. They look like delicate feathers or silky brush strokes painted across the highest reaches of the sky. Once a cloud has formed, its tiny droplets are constantly moving, bumping into each other and merging. This process is called coalescence. As the droplets merge, they grow larger and heavier. Eventually, a droplet becomes so heavy that the rising air currents can no longer hold it up. It begins to fall. This is the moment of release. This is the moment of rain. In colder clouds, water vapor might freeze directly onto tiny ice crystals, which grow and grow until they are heavy enough to fall. If the air is below freezing all the way to the ground, these crystals arrive as snow. Each snowflake is a tiny, unique masterpiece of frozen geometry. Its shape is determined by the temperature and humidity of the air it travels through on its long, silent journey down to Earth. The classic six-sided star is just one of countless possible forms, each one a perfect, symmetrical jewel. Sometimes, a snowflake will fall through a layer of warmer air and melt, only to pass through a layer of freezing air near the ground and refreeze into a tiny pellet of ice. This is sleet, and sometimes rain falls as a liquid through cold air and only freezes the very instant it touches a cold surface. A tree branch, a blade of grass, a window pane. This is freezing rain. which can coat the world in a beautiful, clear glaze of ice, making every twig glisten like crystal. This entire process, evaporation, condensation, and precipitation, is the water cycle. It is nature's endless system of renewal. Water journeys from the ocean to the sky, from the sky to the land, and flows in rivers back to the ocean to begin its journey once more. It is a constant, gentle rhythm that sustains all life on our planet. The skies release thunder and light. Sometimes the atmosphere needs to release a great deal of energy on a hot, humid day. The rising columns of warm, moist air can become incredibly powerful, growing and building into towering clouds that reach miles into the sky. These are cumulonimbus clouds, the giants of the cloud world, and they are the engines of thunderstorms. Inside these majestic clouds, there is a powerful dance of motion. Strong updrafts carry warm, moist air ever higher, while downdrafts bring cooler air and precipitation falling back towards the earth. In this swirling, churning motion, tiny ice crystals and water droplets collide. As they do, they exchange electrical charge. Lighter, positive charges are carried to the top of the cloud, while heavier negative charges collect at the bottom. The cloud becomes like a giant battery in the sky. Eventually, the electrical tension becomes too great to hold. The atmosphere needs to find balance, and it does so in a sudden, brilliant release of energy. A flash of lightning. Lightning is simply the sky exhaling a stream of energy, balancing its charge. It can happen within a single cloud, a silent, flickering dance of light. It can leap from one cloud to another, or it can connect the cloud to the ground below. The channel of air that the lightning travels through is heated instantly to a temperature hotter than the surface of the sun. This sudden, intense heating causes the air to explosively expand, creating a powerful sound wave that we hear as thunder. Because light travels so much faster than sound, we always see the flash of lightning before we hear the deep rumble of thunder. The time between the two tells you how far away the storm is. A longer pause means the storm is distant, its energy releasing far away from you. The sound arrives as a low rolling growl, the deep hum of the atmosphere at work. Sometimes the updrafts inside a thunderstorm are so strong that they can toss raindrops high into the freezing upper levels of the cloud, then let them fall, only to be tossed up again. With each trip, another layer of ice freezes onto the pellet. This is hail. When the hailstones become too heavy for the updraft to support, they fall to the ground. Most thunderstorms are brief. They build, they release their energy and their rain, and then they slowly fade as the downdrafts of cool air cut off the supply of warm air from below. They are a temporary but powerful expression of the atmosphere's constant search for balance. Very rarely, under very specific conditions of wind and moisture, the rising, rotating column of air inside a powerful thunderstorm can tighten and stretch downwards, touching the earth as a tornado. These are expressions of incredible, focused energy. And over warm tropical oceans, clusters of thunderstorms can organize and begin to rotate around a calm central eye, feeding on the warm water below. This is how a hurricane is born. These are the largest and most organized storm systems on Earth. Vast, slow-moving spirals of wind and rain. These powerful phenomena from the single thunderclap to the vast hurricane, are not chaotic events. They are nature's way of moving immense amounts of energy and heat from one place to another. They are a fundamental part of how the Earth's climate system maintains its equilibrium. These are the sky's deep, powerful, and necessary exhalations. The gentle wonders, light and illusion. But weather is not always about grand, powerful releases. Sometimes it is about quiet magic. It is about the interplay of light and water, creating beautiful, fleeting illusions that paint the sky with color. The most beloved of these is the rainbow. A rainbow is not an object you can touch. It is an optical phenomenon, a personal experience between you, the sunlight, and the raindrops. When sunlight passes through a spherical raindrop, the light is bent or refracted. It then reflects off the back of the raindrop and is bent again as it exits. This process splits the white sunlight into its spectrum of colors, just as a prism does. Red, orange, yellow, green, blue, indigo, and violet. To see a rainbow, the sun must be behind you, and the rain must be in front of you. The colors form a perfect arc in the sky, a bridge of light. And because it is an optical effect dependent on your position, you can never reach it. It moves as you move. The rainbow you see is yours, and yours alone. Sometimes light shines not through raindrops, but through high-altitude ice crystals in thin, wispy cirrus clouds. When this happens, it can create a beautiful halo around the sun or moon, a perfect, glowing ring of light. Occasionally, this halo is accompanied by bright spots on either side of the sun, like two faint, colorful copies. These are called sundogs. They are all part of the same family of atmospheric optics, born from sunlight being bent by countless tiny hexagonal ice crystals floating miles above the earth. And then there are the gentle hues of sunrise and sunset. When the sun is low on the horizon, its light has to travel through more of the atmosphere to reach your eyes. The atmosphere scatters the shorter wavelengths of light, the blues and greens, leaving the longer wavelengths, the reds, oranges, and pinks, to paint the clouds in breathtaking colors. These are the quiet whispers of the sky, the gentle reminders that the atmosphere is not just a system of pressure and temperature, but a canvas, an artist that works with light and water, air and ice to create moments of fleeting, breathtaking beauty. Conclusion: the ever-moving sky. And so, our journey through the skies comes to a gentle close. We have floated on invisible currents, watched clouds being born from a breath of moisture, and witnessed the way sunlight and water can paint the air with light. From the vast, slow circulation of the global winds to the tiny, perfect structure of a single snowflake, we have seen that weather is a story of balance. It is the earth breathing, the ocean exhaling, the sun sharing its warmth. It is a system of profound and elegant harmony. As you continue to drift now, deeper and deeper into rest, know that the atmosphere continues its silent, steady work. Somewhere, a gentle breeze is rustling through the leaves of a tree. Somewhere on the other side of the world, The sun is rising, its light beginning to warm the land. The sky never truly sleeps. Allow the gentle rhythm of your own breath to merge with this vast planetary rhythm. Inhaling and exhaling. There is nothing left for you to do now, but rest. Rest well. May your sleep be deep and untroubled, and may your dreams be as soft as fog and as bright as a morning after rain. Sleep now. Sleep